This lesson is about solving a system of linear inequalities. Let me graph, instead of doing a whole system, let me graph just one inequality, linear inequality. That way you'll get the hang of how to graph this. Notice this is like a line. Instead of the equal sign, it has less than or equal to. You're going to first start graphing it like a line. So negative x plus 3, notice it has a y-intercept of 3. And then the slope happens to be a -1 slope. So you're going to start graphing this like you normally would. All right. Notice it says less than or equal to. So I want to graph all of the points that are less than or equal to that line. So that means everything that's lower than the line. So you're literally going to shade every point over on this side of the line. And if you're not sure like which side is less than, what you can always do is test a point. Pick any point on anywhere on the entire graph. I normally choose 0, 0. As long as it's not on the line, you can test any point that's not on the line. So what I'm trying to do is I'm going to see if this point will work. If this side of the line works, again, you can choose any point over here or any point over here. So if this side works, then everything over here will work. So I'm just choosing a certain point. So I'm going to put 0, 0 in for x and y. And notice this is a true statement, which means every point over on this side would work. So I'm just going to simply shade this side of the line. And again, what that implies is everything is being included that's less than that line. So you're going to shade everything less than that. Let's try another similar problem to it. Again, you have negative x minus 1. So you're going to start at the y-intercept of -1, and it has a negative slope. But I want you to notice on this one, it has a greater than sign and not greater or equal to. So it's strictly, when I connect these, connect this to make a line, it does not include the line. It is only greater than the line. So we're not going to draw a solid line. We're just going to draw a dotted line to be able to do that. So we're just going to literally make a dotted line through that whole thing. And you're going to shade one side of the line. And it does say greater than. So again, I know that it's up here, but if you don't know which side is greater than, if you can't see that, just pick any point on the entire graph. Again, I typically choose 0, 0. I'm going to substitute that in. As long as it's not on the line, just choose any point that's not on the line. And so you get this statement. Well, that's a true statement. So this blue dot, which is on this side of the line, does work. So I'm going to shade everything on this side because it does work. Now let's try our first system. Remember, the whole purpose of this video is to graph a system of inequalities. So I'm going to first graph the black line. Again, negative x minus 2. So it looks like this. Notice that it is a dotted line. It does not have an equal sign. Then we have the blue line, 3x plus 6. So you're going to start at 6. You're going to go up 3 over 1 or down 3, 1 to the left. And this will be a solid line. Now, I want you to notice it. By drawing two lines, it creates 4 areas. You have an area right here, you have an area there, an area there, and an area there. So there's literally 4 different sections. And only one of those sections will be colored in. And again, it says greater than. So on the black line, it's everything above the black line, and the blue line is everything less than that. And again, if you could see it, then go ahead and shade that in. And if not, what you need to do is just test a point. Pick any point that's on the entire graph as long as it's not on the line. I am going to choose that 0, 0 point again. And we're going to test it in the black line first. So put 0, 0. Put 0 is greater than -2, which is correct. That's a true statement. So according to the black line, this point does work. So notice it's above the line. So any of these two sections will work. That's above the black line. Now on the blue line, if I put 0, 0 in, that's a true statement. So according to the blue line, these two sections will work. So what's in common is this one whole section. So you're just going to shade the common section in. So notice this section is greater than the black line, and it's also less than the blue line. All of these points have that in common in that area. Another illustration, just same thing, just go through the same process again. -x minus 4, if this is my blue line, let me switch to blue. So this is starting at -4, and I'm going to go up 1 over 1, up 1 over 1. Notice this is a dotted line. Because there's no equal sign. The red is starts at positive 3, and you're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. This one's a solid line because it has the equal sign with it. And again, notice it makes 4 sections. 1, 2, 3, 4. 4 different sections. And you're only going to shade one of those. Again, it's got to be less than the blue. It's got to be greater than the red. So that's what we're looking for. Well, I'm going to choose a point. Well, you know which point I'm going to choose. I'm going to choose the point 0, 0. Let's plug it into the blue line. If I put 0, 0 in, that 0 is less than -4. That's a false statement. So according to the blue line's right here. On this side of the blue line, it does not work. So only on this side, one of these two sections will be shaded. One of these two sections will be shaded. Now let's go to the red line. I'm going to put 0, 0 in again. That's a false statement. So again, what I'm doing is on the red line is I'm testing this side of the point of this red line. I'm testing this side, and it does not work, which means it's got to be this side of the red line. Well, remember a minute ago, I found out that it was this side of the blue. Now I just found out it's this side of the red. So what's in common is this little area. Again, all of these points in here will work on both of those equations. You can actually check that too. You can actually just pick some random point in here, like 10, 0, and plug it into the blue equation and plug it into the red equation and see if it works on both equations. So every point in here, every single one of these points in here will work on both of these two equations. Just on this one, I'm going to do this one even quicker, but notice you have to, well, let me graph the blue line first. The blue line is actually kind of easy. Y is greater than 2. If you remember the Y's, if you think of Y's are a horizontal line, so Y is greater than 2 is like this. Y lines are horizontal lines. X's are vertical lines, so but Y's are horizontal, and Y is greater than 2. That means everything above the line. That's what that means. Everything above the line will be shaded. I'm not going to shade it yet, but just keep in mind that Y is greater than 2, everything above it. Now let's look at the red line. First, to graph it, most of us usually solve for Y equals mx plus b. If you do it this way, you've got to remember something. When you divide an inequality by a negative sign, it flips the symbol, the inequality symbol. So this is what we're actually graphing here. And again, don't forget about that. When you divide by a negative or multiply by a negative, it changes the inequality symbol. So here we're going to graph positive 2. We're going to start at positive 2. And we're going to go up 1 over 4. Up 1 over 4. And notice it's a dotted line between those. I'm just going to dot these guys. And notice it creates 4 sections. Again, we have a small section here, we got a big section here, a small section there, and a big section there. But it creates 4 different sections, and I'm only going to shade one of those. Well, remember a minute ago we started graphing the y is greater than 2, and so that means everything above the blue line. So I know it's going to be one of these 2 sections, all right? So what I'm going to do is I'm going to pick a point that's above that. I want to find out which one I want to do that. I want to find out if it's going to be on this side of the red line or if it's going to be on this side of the red line. Because again, I already know it's going to be above the blue line. So I'm going to test a point if it's going to be below or above the red line. I'm going to test that wonderful point 0, 0 on the y line. So I'm going to put 0 in for y and 0 in for x. So I'm going to end up with this, which that is a true statement. So everything below the red line works, but remember it's got to be still above the blue line. So what this creates is this little small section in here gets highlighted. That little section is what's common. And again, to check it, every one of these points in here, every single one of these points in here will work on both of these equations. And this problem is very similar. Again, you have y is less than or equal to 4, so you have a line going across at 4. You have 3x minus 1, so it starts right there. It goes up 3, 1, 2, 3 over 1, 1, 2, 3 over 1. And so you have a solid line going this way. And I'm just going to do this freehand, but it looks like this. And notice it creates 4 sections. This says less than or equal to so it has to be one of these 2 sections because it's lower than this line. It's lower than this line right here, so it's one of these 2 sections. And I'm going to test the point 0, 0. So 0 is less than -1. That's a false statement. So again, this point 0, 0 does not work. So it's got to be on the other side of this line. So what's in common is this section over here. I hope that helps you graphing a system of inequalities.